Alright, so I believe that this is recording. We are taking a look at rational functions. A rational function is just a ratio of two polynomial functions. They're asking us three things: to identify the domain of this function, and then to examine the domain and illustrate, to think of the graph, or to show that in the graph anything excluded from the domain is going to appear as a vertical asymptote or as a whole. So normally when we're finding the domain of a function, we also have to consider never taking the square root or even root of a negative number. But with a polynomial in the numerator and denominator, we don't have square roots in a polynomial function. So the only thing that we have to worry here is about division by zero. So this is all about factoring the denominator, or using the quadratic formula, or some type of methods, either rational zero theorem, something to factor and to solve this denominator if we set it equal to 0. Well, I notice here that all of these numbers are divisible by 6. So let's factor out that greatest common factor of 6. And we have x squared minus x minus 2. And then we see that this now factors to 6 times x plus 1 and x minus 2. Okay, let's double check that. When I factored the 6 out, I still would have negative negative. When I have since this is negative and the middle term is negative, the larger value will be negative. 2 is negative, that's bigger than 1. So everything appears to me to be correct. My domain is a set of all real numbers, excluding these values that cause division by 0. We're going to exclude a negative 1, because negative 1 plus 1 would give us 0. And we're going to exclude x equals 2, because 2 minus 2 gives us 0. Neither one of these factors reduce, so both of these are producing vertical asymptotes in the graph. So our graph has two vertical asymptotes. We need to give the equation of the asymptotes, not just a number. It represents infinitely many points, and I like to emphasize that it is a line, and that's not necessary, but like I say, it's my preference. And here it's a line x equals 2. These were the two values that were excluded from the domain. They do not have a corresponding y value. There were no holes in the graph. So let's go and see if we can illustrate this using this online graphing calculator. Get rid of our previous problem. I'm just using the index of 5 to indicate that I'm working on problem 5. I'll put parentheses around my numerator so it doesn't divide just by the second term, but the binomial is what's being divided. And in the denominator, I have 6x squared minus 6x minus 12. And so, yeah, it does appear that there is two vertical asymptotes. Let's put those in as dashed lines. X equals negative 1, x equals 2. That's just making it easier for us to read. Let's make the original one black, that's easy to see. We'll make this one blue, or at least we have been, and make it a dashed line. And blue and a dashed line. Alright, so let's take a look and see if we agree with this. Yeah, here at x equals negative 1 and at x equals positive 2, and that's what we said, that at negative 1, at x equals negative 1 and at x equals positive 2, those were vertical lines, and they're illustrated by these blue dashed lines. Our graph, if we zoom in, gets closer and closer and closer to those, but it never touches. If you zoom out, it does down here appear that it touches. Well, that's just because you're not zoomed in close enough to see that there is some distance. If you zoom in close enough, then you can see that there is some space there that you just don't recognize when it's zoomed out. So I hope that helps, and I will talk to you later.